I will start with some obvious sentences just to explain the motivations behind the idea of the FreeWatt project. FreeWatt is a simulation platform to simulate groundwater dynamics and all the other related processes, such, for example, solid transport. And so, as you know, when we deal with an aquifer system, usually we deal also with the analysis of the water balance. And when we face with these challenges, with this analysis, very often we deal also with overexploitation of water resources due to human impacts, so human water demanding activities, and deterioration of water quality due both to human impacts and climate changes. But as the water is at the center of this nexus among food, energy, health, climate, and environment, it is of paramount importance to address some planning and management activities. And so this is a central issue for local, regional, and national governments. So the need to have some proper tools to address proper management strategies for water uses. And so basically we try to answer these three questions. So do we have such proper tools to face challenges related to planning and management of water uses? And do we just need to collect data, and eventually are we able to fully exploit the data, the available data for water management purposes? And as boosted also from the European Water Framework Directive, simulation tools, numerical tools are valuable tools to address some such questions, as they allow to evaluate the behavior of the aquifer system under exam, and eventually to provide some forecasts about the evolution of the system. And as a further answer, integration between geographic information system, GIS, and modeling tools may be a pretty good tool to answer these questions. Because the modeler can take advantage of both the capabilities of GIS in terms of storage, analysis, and representation of geographic data, and it can take advantage also of the capabilities of numerical tools in terms of generation of simulation scenarios, and to provide guidelines to address water management strategies. And in this framework, the FreeWatt project is a Horizon 2020 project financed by the European Commission. And FreeWatt stands for free and open source software tools for water resource management. So the aim is to improve, of course, water resource management through the development of these free and open source modeling platform, fully GIS integrated, to simplify and boost the application of Water Framework Directive, Groundwater Directive, and other water-related directives. This is accomplished through the use of innovative data analysis tools, and through the inclusion of a participatory approach. Participatory approach means that all the relevant stakeholders involved in the management activities of a certain system are involved not only in the final stage of the model generation, so basically where results are presented, but since the beginning of the model generation, so that, for example, the modeler can share with all the relevant stakeholders also the data which he is going to use to build the model. And FreeWatt is coordinated by Dr. Rudy Rossetto, Scuola Superiore Sant'Anna, and partner, Oslandia, which actually doesn't really deal with the software development or application of the platform, but it deals with software engineering, so review of the code in the final stage of the development. The project started on April 2015 and will end in September 2017. And the activities can be basically grouped into parts. The first part includes work packages 2 and 3, devoted to software development and capacity building, and these activities started at the beginning of the project until July 2016. So let's say that the platform is basically done in the current version. And the following part of the project will deal with the application of the platform, so testing the platform to specific case studies from now on. And since the beginning of the project, several stakeholders were involved, also through web, social, and professional networks, and the most of them, almost 100, actively participated to the development of the platform from several countries, mostly from Italy, Spain, and Greece, and also from several kinds of institutions, so research institutions, water utilities, national authorities, and so on. And they demonstrated to have skills both in GIS and hydrological modeling. They were actively involved in the development of the platform, in the sense that they were asked to reply to this survey and to indicate their needs and priorities, so basically their expectations from this platform, specifically related to the case study to which they are going to apply the platform. And so among the major areas of interest, there is the assessment of water quality, especially related to agricultural activities, or also related to interaction between groundwater and surface water bodies, like for example, to assess saltwater intrusion phenomena in coastal areas. And so according to the outcomes of this survey, what is FreeWatt today? It is a fully GIS integrated platform. As the platform is free and open source, we decided to adopt QGIS as a GIS interface, and specialized as a database management system. And so far, the platform includes both pre-processing tools and tools to build the model. So about the pre-processing tools, there are two tools, one for the analysis of time series, and the other one for the analysis of hydrochemical and hydrogeological data. Then regarding the modeling part, there are several packages, Monflow based, to simulate groundwater flow and interaction with surface water bodies. that you are going to model is simplified, is represented by a series of blocks. So in the horizontal plane by a series of cells. And so these model data objects are contain information about the spatial discretization of your model and also about the time discretization of the whole simulation length. And they are all stored into the spatialized database, which can be easily shared with anyone. And the last step deals with the translation of these model data objects into input files for simulation codes, which are basically text files. This step is automatically done when you click just a button. And so this is, let's say, really advantage because otherwise the model has to write these files by hand or using any other interface, not GIS integrated. This is how FreeWorld looks like today. It is a plugin to be installed and activated in QGIS. So it is simply a menu in the toolbar of your interface, and more or less each of these sub-menus relate to a specific process to be simulated. And as you can see, you have in a unique platform both pre-processing tools and tools to build your model, but also post-processing tools to visualize your results, so to create maps and so on. So far, this platform has been widely tested, as we will see in a while, but due to the open source characteristics of the platform, FreeWorld philosophy includes this initiative ad includendum, which means that basically everyone can contribute to the development of the platform, both by reporting bugs, so testing the platform and eventually reporting bugs, or suggesting or developing new tools to be integrated in the platform to simulate some other processes. And about the FreeWorld history, the first version, which was called alpha version, was released on December 2015, and the last one on July 2016. All these versions were released just to the FreeWorld partners, actually, but under a certain agreement, actually it was used also for example, for teaching activities and for testing, of course. And the platform was complemented also by 6 user manuals, one of each of them describing a certain process to be which can be simulated. And from December 2015 to July 2016, set training activities were carried on, as I said before, by both project partners, but also by some other volunteers, let's say. And during this first phase, the participants dealt with QGIS training and mode flow training, so they explored, let's say, just the groundwater flow modeling part. While in the second part of the training, from May 2016 to July 2016, we traveled a lot all over Europe to have these 1-week courses at the partner countries and to spread the knowledge also about all the other modules integrated into the platform. And this phase was called Training the Trainers because actually the participants to these activities are supposed to be And among these 14 case studies, 9 will be devoted to the application of Water Framework Directive, Groundwater Directive, and so on. And the remaining 5 will be devoted to rural water management, among which there is also transboundary aquifer among Namibia, Botswana, and South Africa through the involvement of UNESCO to boost the application of such free and open source tools in those countries. And now just a few minutes to provide an overview about all these tools integrated into the platform. So first of all, the pre-processing tool AcvaGIS, developed by colleagues from IDEA-CSIC in Barcelona. And AcvaGIS is a pre-processing tool needed to develop a conceptual model prior to build the numerical model. And it includes several sub-menus, so several tools to analyze the hydrochemical and hydrogeological data which are stored in well-structured spatialized database. And these tools allow to create salinity diagrams, pattern diagrams, stiff diagrams, and some thematic maps, so to build a proper conceptual model. As a further pre-processing tool, OAT, Observation Analysis Tool, was developed by Sussi University to analyze time series. So you can import your sensor data both from servers or local files and manage and edit your data and perform several operations like the same thing, filling, and so on, and eventually display and compare sensor data. And these capabilities are really useful in the pre-processing part, so when you prepare your input data from your model, or in the calibration phase. Regarding the modeling part, as I said before, the groundwater flow dynamics is simulated through Montreal Twins version 2005. I think you all know this code developed by the USGS to simulate single-phase saturated flow at constant density in heterogeneous and anisotropic porous media, both at steady state and transient conditions. And as I said before, ModFlow is based on a finite difference approach to represent and model, and so to approximate the groundwater flow equation. So basically, your domain, your aquifer system is discretized through some blocks with varying spacing and variable thickness. And ModFlow is complemented also by several packages to represent several kinds of conditions and sink and source terms. So all these packages are integrated into the framework. And all the other codes to simulate other processes are all of them ModFlow related, so they are fully coupled with ModFlow. For example, for solid transport, MT3DMS and CWAT are integrated it can deal also with some other aspects, let's say, of the water management. It allows to simulate the whole hydrologic cycle, dynamically integrating supply and demand components for specific subregions of the model as part of the simulation of surface and groundwater flow. And such subregions are still a group of cells, so again the full integration with model, which is always grid-based. And such subregions in farm process are called farms, but actually in FreeWatt we prefer to use the term water unit, because a farm is not necessarily an irrigated district, but can be also, for example, a urban area which needs water for some other activities. And so for each water unit, the demand is, can be satisfied by conjunctively using surface and groundwater resources according to this scheme. So let's suppose to have a water unit which needs water to satisfy a crop demand for plant transpiration. And as a first attempt, the code will try to satisfy this demand from natural supplies, so by precipitation and root uptake. But if not, you will have an irrigation need, an irrigation demand. And at this stage, you can also define an urban demand, so an external demand for some other water-related activities. And as a first priority, this demand is tried to be met by surface water supplies, so by a network of surface channels or by any other external source. But again, if surface water supplies cannot fully meet this demand, you can go to groundwater. So you can pump groundwater from what are called farm wells, which are wells which deliver water to specific water units. But for each farm well, you can also define a maximum well capacity. And again, if you need more water with respect to the maximum well capacity, you will get a deficit scenario for that water unit. And here, you can decide to optimize your water use. In FreeWatt, there are two different optimization methods. You can define a priority for your crops, so the water will be delivered first of all to the crop with a major priority and so on. Or you can decide to use an economic optimization method. So you will balance for each kind of crop your costs and benefits, and you will deliver water first of all to the crop with a better ratio, let's say, between costs and benefits. Yeah, I'm just. And last but not the least, the module for sensitivity analysis, calibration, and uncertainty analysis is based on UCode in its version 2014, again fully coupled with Modflow. And the major aim is to answer this question: how does my model relate to the real world? And how can we answer this question? Basically, we can analyze the behavior of our model through some sensitivity indicators. And then eventually we can go through an automatic calibration method based on nonlinear regression to reduce the most uncertain aspects of our model, so that we get the best possible fit between the outcome